Solve the following equations. 7,776 is equal to x to the fifth power. So notice that in this equation the variable is being raised to a power, whereas in the previous examples we might have had something like 3 to the x equals a number. Here the variable was in the exponent. This is called an exponential equation, whereas the equation we're dealing with now is called a power equation. And the methods for solving power and exponential equations are not the same. Generally, to solve a power equation, we are going to use powers. And so to solve the equation 7,776 is equal to x to the fifth, my goal here is to make this an x to the first. And so what I'm going to do is I'm going to use a property of exponents. If I raise x to the fifth to the 1/5 power, if you remember your rules for exponents, that would tell you, well, to multiply the exponents. If you raise a power to a power, you multiply exponents. And 5 times 1/5 is 1. And if I raise one side of the equation to the 1/5 power, I must do the same on the other side of the equation. Now, 7,776 to the 1/5 power is not a simple task. Let's use a calculator. 7,776 exponent. Now let's make sure to put that 1/5 in parentheses to tell the calculator to evaluate the 1/5, the division, before the exponentiation in this case. We hit enter and it's exactly 6. So then x to the first power is 6. All right, so x equals 6. And we could, of course, check this. What is 6 to the fifth power? 6 raised to the fifth power is 7,776. X to the fourth is equal to 182.25. I'm going to use a power here, but first I want to isolate that x to the fourth. The x to the fourth is being multiplied by 36, so I will undo the multiplication by dividing through by 36. So that yields x to the fourth, and using a calculator, x to the fourth is 5.0625. And now, like before, I want x to the first power. So what I will do is I will raise that x to the fourth to the 1/4 power, and do the raise to the 1/4 power on the right hand side. So then x to the first is, let's see, 5.0625 to the 1/4 power is 1.5. So x is 1.5. T to the fourth divided by 20,000 is equal to 52.4288. So again, I'm going to use a power eventually, but first let's get this t to the fourth by itself. Now in this case, the t to the fourth is being divided by 20,000, so what I'm going to do is multiply by 20,000 on both sides of the equation. That yields t to the fourth is equal to 1,048,576. Now again, my goal is I want a t to the first power. So I will raise both sides of the equation to the 1/4 power. That will give me t to the first, and let's see, 1,048,576, raise that to the 1/4, yields 32. So t is 32. 4n to the 7th plus 300 is equal to negative 8,448. Again, my first goal is to isolate that n to the 7th. So to isolate the n to the 7th, I will first subtract 300 from both sides. So then 4n to the 7th is equal to negative 8,748. And then I will divide through by 4, yielding n to the 7th is equal to negative 2,187. And then finally, remembering that I want an n to the first power, I will raise both sides of this equation to the 1/7 power. So that would give me n to the first on the left-hand side. And let's see, open quantity, negative 2187. Raise that to the 1/7 power. That gives me negative 3. So n to the first is negative 3. N is negative 3.